today we
Okay.
started binary heap.
Nice. Okay.
Yeah.
That's fine. So let's talk about the top 5 interview questions, which is pretty much similar to you. But today also I will give you only the overviews of the remaining 4 questions. How much did you learn, and what else we can do to improve your, what to say, coding expertise, like solving any tree problem within 20 minutes. That's something is our goal, right? Mostly we have hardly 1 semester left to start internships. So we need to do as many programs as we can. Personally, working extra mile compared to others. So let's go back to our previous session, the top 5 questions, and then where did we leave and how would we improve further? I'm sharing my screen. Hmm. This thing, the program is already available. That's nice. But let's go to the second program, binary search tree validation. Do you know what is that?
No.
Very simple. You have done that in your assignment, looks like. Validation means 2 is a root node, and it has 1 and 4. Is it a binary search tree?
Yes.
That's it. That is what you need to do in the program.
Okay.
Now, is it a binary search tree?
No.
That's it. That's what all you need to do. So they'll ask you to write a program to validate whether a given tree is a BST or not. So what is the logic here? Tree is already constructed by them, technically. They'll give you the root node. Yeah. No, yeah, you were speaking something.
Like going through each node and seeing if it's like greater than the one before it.
That's correct. Left children should always be less than
Smaller.
the root, whereas the right children should always be equal or greater to that root node. Here you should confirm with your interviewer. What if, is it correct? This part only. Or say, let's take 20. And the left part is also 20. You should check with your interviewer. Sometimes this is valid case. Root and left subtree can be same, but sometimes they don't agree. They would ask you to put the right side, the right sub equal value. So you can double check with your interviewer, but it's a minor test case. They don't mind even if you assume, but you should mention to them. That's one interview tip. Second one is you should always use the word recursion. You need to recursively validate 3 nodes, root node with left and immediate right, and recursively do the same for its left subtree and then the right subtree. It's exactly same as in-order traversal or any order traversal, preferably in-order traversal. But the difference is in the in-order traversal, we just print the data. Now we need to add a if condition. This is the one. Root node. For now, you ignore these. These are again for validations to make sure we are not going into infinite loops. But you can just understand the condition is this one, which you have already mentioned. If the root is null, return. If the root value is less than or equal to minimum value, what is the minimum value? Initially, they are giving minus 9999999. That is the longest minimum, because for the first row, it is lowest minimum and lowest max they are giving. From the second row onwards, they are giving the real values. I'll show you that. This is the second row onwards. Return is valid BST. Suppose if the root is not null and root dot left value is less than minus 999 and more than plus 999. Sorry, continue. And then root dot left, do the same for the left subtree by passing the original minimum value. What is the original minimum value? Technically, it should be immediate left, but this is just an additional recursion call. But slowly, if you draw the recursive tree, you will understand. But I will give it to you. How many recursive calls will happen in our example? Just think in that way. I will get more. We have 1, 2, 3, 4, 5, 6, 7 nodes. How many recursions will happen here?
7 times.
Can you, if we draw a tree, root dot left, 1 recursion call, root dot right, 2 recursion calls. So at row 1, 2, you're right. And then here, this is the root. So this will have left and right, another 2. Also, this will have left and right, another 2, 4. But they will also make additional recursion calls, right? Until they terminate.
Oh,
So each one will
okay.
have again 1, 2, 2, 2, 2. So you need to add those as well. So always try to draw that recursion tree and then play with it. However, do you get confidence about this problem?
I'm still confused about the minimum value. Like,
Or
why do
this
you need to
part?
check the minimum value and not the node?
I'm just thinking, what is the best way to explain you? I can draw a tree and explain you, but
Okay.
in the interview, I just finding what would be the right approach for you to impress the interviewer. The best one of the ways is going through the main. Take the root dot left is a node 1, root dot right. Okay, this is all construction part. Um, calling is, where are they calling? Yeah, just sending the root. Okay. Initially they're sending, okay. Mm, suppose the challenge where it comes is, if we don't have this, this is one approach they have given. I'm just finding even any better way which I can share, and then the challenge. What you could do to avoid this challenge. Technically, it is only for C++, but from Java onwards, or I think it's not that. Even in C++, we can avoid. I understand. This is pretty old style. I understand your question. And the better style is send the root. You understand this part?
Yeah.
So 20 is greater than 20 dot left. Left child is more than the value, root value. In that case, return false. The other one is, I'll pass you, sorry, right value is less than the root value. In that case, also false.
Why is it returned false and not true?
Because it is not a BST, right? If I have 23, is it a BST?
Oh, no, no. Okay.
Root is 20, dot left is 23. 23
Okay.
is less than 20. It should be, but it's not. So return false means it's not a BST. You can do this way, or you can use min and max values by passing this.
Okay.
Don't worry much. Uh, Second is, as long as if you do this and practice, you will get many more ideas. But for now, I'd like to change this. You don't need to really care about all this. But you need to add more conditions now, right? If the root is not equal to null, then this is good. What if it is like this? Here, this will fail, right? 2023, okay.
Yeah.
20 is 23 is okay. 20 is less than 2, true. That's good. But 20 dot right is null. This is null, right? The comparison is not correct. So your compiler will give an error.
Okay.
So this will be fail in that case. That's the reason I would like to use min and max. And if they are null or empty, we can pass different values. So that's why we need to use those min and max. But if you don't want to use those, the other way is you can add more if else conditions like this. The other condition is like this. If then you can return false. Make sense?
What is the symbol after the null mean?
This is
Is it
double
and?
and yeah.
Okay. Okay.
So if root dot left is not equal to null, and then the root dot value is less than root dot left value, then return false. Okay.
Okay. That makes
Similarly, else if, or maybe you can even use a simple if. If root dot right is not null, root dot value is less than, or maybe this is greater than root dot right value, which is incorrect. In that case, also return false. So you need to write in this way. If it is empty, return true. That's okay. All good. If it is not empty, but its left node is not empty, validate. If its right node is not empty, then also validate. We have done all. There neither left node is neither null, also right node is nor null. Then validate both right and left nodes. Okay, this is one way.
Okay.
So what does it mean? It will validate left node and keep returning you either true or false. Similarly, keep returning you true or false. If all the cases are true, then only you will return true. Otherwise, you will return false. This is what you should
Okay.
explain to your interviewer. Looks easy, right? But if you test it with all the possibilities, you'll get more learning. But I would like to give you this part, which is very important in the interview, to write within 10 minutes and explain for another 10 minutes. Okay? Any doubts?
No.
Good. Now let's go to the third problem, max depth in a binary tree. Do you know this problem?
No, I think we've touched it in class, but
Mhm. These are available in anywhere in the internet. Let's see about that website. Oh, it's gone. Something happened to this. This is the book I've been saying, right? So this book author is having a website, but now it's no longer exist.
is it careerup.com or .ca?
.com, careercup.com.
Oh,
Otherwise, we can search in other websites.
it's working for me.
Oh, that's amazing.
I can paste the link in the chat.
Why it's not working for me? Oh, sorry. This is amazing. So now, oh no, it is career up, not cup.
Oh, is it different?
Yeah, it's different. That's fine. You have these interview questions, right? They are available in anywhere. This is the way we can go through topic wise Amazon SDE, how to study and how to do, because we don't have enough time to discuss everything, but they have given you detailed concepts. You can right away go to the tree. It can be lead code also, but you always should target the company which you are doing, practicing for. So first start with Amazon, then go to Google. So these two companies will cover 80% of the DSA questions. And then you can go through the relevant company, whichever is calling for you in the campus. Okay. Otherwise, I may explain you 10 or 20, but it's not enough. You should keep practicing like this apart from your assignments.
Okay.
There is a tree. You want to- oh, that's okay. Yeah. Tree. So in order traversal, pre-order traversal, kth largest element in a BST. What is that? Left view of a binary tree, right view of a binary tree. Check for BST. Just now we have done. Diameter of a binary tree. Do you understand? What is the
Yeah.
kth largest element in BST?
The max or min value?
Kth. It's not the max. So this is the question. If in the following bit tree k is 3, you need to give third largest element. What is the third largest element?
Oh, okay.
The highest value is 22, first largest, second largest. 14 is the third largest. How do you do that? So just practice. So this is the code also available for you with the solution. Okay. So we need to keep practicing, as I said, 20
Could
to 30.
you paste the link in
Sure,
the chat?
sure. All these are target company based. Amazon, these are not enough, but this will definitely give you opportunity to prove as an intern. But these questions are not just for intern, they are for ST1, even ST2 also. For ST1, it will cover 3 interview rounds. For ST2, it will cover around 1.5 to 2. ST2s need system design and their project experience. But interns, you have zero expectations from project and systems design. All is coding, trees, graphs, all these topics. Recursion, dynamic programming, apply for trees, graphs, strings, and arrays. Mainly, and of course, stacks and queues are part of those. So these questions, I'll add it in the link, live link. This one is also good, but this is only Amazon ST sheet, right? Let us search the same for Google. This is the next set. You can start. Solutions also there. You just need to practice those, understand the logic, draw the dry runs, validations, all that. Same story. You have a lot of questions. As under half of these are repetitive. The only difference between, I would not say only, but key difference is Amazon doesn't ask you bitwise operator questions, but Google does ask sometimes. Remaining questions, 70 to 80% are same. But Google expects more of computer science fundamentals too, little more depth. But they pay also a little more than SDEs at Amazon. But it is country to country. In India, Google pays more than Amazon. But in North America, they both compete based on your performance in the interview and the number of internships you have done. These two matters. I wouldn't mind you doing internship in both these companies, whichever comes first. If you get Amazon internship, you will easily get Google job and vice versa. But getting that first job needs preparing for both. 60-70% questions are copy paste. You can see both the links. Okay, so if you do those, then these 5 questions will be pretty easy compared to those 20 to 30 questions. So please start like that. But today I would like to show you how to at least, remember what topics and where to cover and how to do. Do you have any doubts so far?
No.
Cool. What is your confidence level now to crack these companies?
Um, I'm more confident than what I started, but I just need to actually code them because that's where I struggle with. But I understand the concepts.
You need to code, but code is already available to you. You need to practice. But
Yeah, the practice.
understanding the key 4 lines in each problem is very important. Only 4 to 5, but they are all recursive calls. I have shared the video description also in the previous video. In this video also, I'll give you. You need to draw the recursion tree like we did in the first session, very first session, for each of these problems. Every problem in tree graph deals with recursion. every problem. Without understanding that fundamental recursion problem approach, we can't able to perform well. Writing code is last option, but understanding those 4 lines of recursion code is the must. Even if you make some mistakes in the code, they're fine as long as those 4 lines are correct. You don't need to write 20, 30, 40 lines, but the recursive code must be spot on. And all these 30 or 20 to 30 questions do have the same, almost same recursive logic. Adding recursion either in the inside if condition or a loop, or storing some recursion output in another place. That is called dynamic programming. That's it. Most of these are pretty much same. Or splitting problem by 2 halves called recursively. Just now we did that. Left subtree recursion is one, right subtree is other one. But in our first session, we did the split in 3 modes. But here they have done it in 2 modes only. So I think that they also 2 modes. So, this is what, Rishita, we need to approach in next 5 to 10 sessions. We have to seriously start understanding 4 to 5 such key logic from all these websites directly, rather than doing one problem in each session. Let's go to the website, go through the first, we can go through another 5 or 10 list of problems, understand the problem, pick up only the core logic, how that is operating, getting that idea. If you just give the idea, you have solved half problem. In this session, you have given very good idea, right? I need to do just an if condition to do. That is very good thought process which is a starting step. But if condition in a loop or a recursion call, how do you do iteratively or recursively? And how many recursions you need? That is second step. And third one is just explain with proper input output conditions. Real example. That's it. Cool. So yeah, I'm very confident that you will crack one of these companies, hopefully as a first or maybe second job, but we will target first job itself. Okay, you know, right? Uh, your senior, 4th year senior is now working as an intern. Last month she has joined with Amazon, Alexa team, Sushmita's team. Okay, and not only she, I think couple more interns also joined from SFU. But it is her second internship. She did work in some small company as a first intern. And same thing like you, she has spent around 1 to 2 semesters only on problem solving with recursion and dynamic program. All these questions she targeted specifically for this Amazon and then got the job. Okay. So I would want you to do the same. If they are doing that many SFA students, why not you?
Yeah.
Okay. See, first of all, if I'm the interviewer, I'm already impressed for SFU and UBC students because your universities pick best talent from the school days itself. So they don't simply take people who are not serious. So they bring the best talent already into the campus across the globe, from the globe. Now all this much best talent is there. They want best of the best because Amazon doesn't have thousands of jobs.
Yeah.
So Amazon wants best of the best. How would you prove yourself as the best? If you just study what your professors are saying, you can prove, right? You have to spare your time for these links and do. That's what all the selected students are doing. And interviewer, and it's not about the quantity, quality. Those 4 lines matters a lot for the interviewer. Okay. So when shall we meet and practice another 5 more problems? Maybe, yeah, 5 to 10.
We can do Wednesday.
Okay. And if you get time, please go through
Yeah, I'll
any of
try to
those links.
finish my assignment so I can. Yeah.
Oh, okay. Don't write the code through hands-on. We can definitely
Okay.
do that. We can definitely do that before the interview. But right now, our goal is to understand 10 to 20 problems and getting the ideas.
Okay.
Once you get the idea, then start coding 1 or 2 problems, and the remaining 18 ideas are copy paste of the same, just changing left code to right code, right side code to left side code. That's it. Okay.
Okay.
So next session, let us just, I'll also try to bring out problem and the idea, and then those 4 lines of key code. So you'll
Okay.
understand, and you will get much more confidence as you understand variety of problems on the topic which you are very familiar with now, BST and binary trees. That's it. Okay. And how about graphs? Did you get the graphs concepts
We didn't do graphs.
yet? Okay. Then it's pretty good. Graphs will be more easier if you solve at least 10 solid tree problems. Okay.
Okay.
Let's target them on Wednesday.
Okay.
Okay, Rishita. Do you have any doubts?
Thank you. No.
Okay. See you on Wednesday.
Thank you. Okay,
Bye.
bye.